Hi guys, welcome back to the channel. So as we know that monitoring heart rate has become essential these days, and many smart devices are capable of measuring heart rate or pulse rate these days. But have you ever thought that how they work and how you can build your own heart rate or pulse rate monitor? Well, if you are thinking about building one, then you are in a right place. So today we will build a heart rate or pulse rate monitor with MAX30100 heart rate sensor. So without wasting any more further time, let's do this. So guys, previously I made a video on heart rate or pulse rate sensor. So please watch that video before starting with this one, so that you could get a better idea about these sensors. So today we will use MAX30100 to read heart rate data. So before we start, let me tell you something about MAX30100. So if you are trying to make it work with Arduino Uno or any 5-volt logic level microcontroller, so let me tell you that it won't work. And the reason is that the circuit design of this module is poor. The SDA and SCL pins output voltage of this circuit gives around 1.8 volt, and which is not ideal for 5-volt logic level microcontrollers. And that is their biggest fault. So because of this low I2C pins voltage, it will not be visible to Arduino Uno or any 5-volt logic level microcontrollers. Well, to fix this there are few modifications that can be done. But today we will not modify this module. We will try to make it work without any modifications. Since 5-volt logic level microcontrollers cannot detect it, so we will use 3.3-volt logic level microcontrollers. So with those it will work, but it will be a little bit unstable. Anyways, it's worth a try, right? So for this job, my first pick would be Arduino Pro Mini with 3.3 volt and 8 megahertz. And second pick would be Nodemcu because both works on 3.3 volt logic level. So let's start with Arduino Pro Mini first. So let's connect Arduino Pro Mini to this module. The connection is quite easy. Please follow the shown schematics to connect everything. So as you can see, I connected everything. Now it's time to open Arduino IDE. Then install the MAX30100 library in your Arduino IDE. After installing the library, go to Examples and open MAX30100 minimal example and upload this code to your board. Then open serial monitor and put your finger on the sensor. And in your serial monitor, you will be able to get your pulse rate and oxygen saturation. Now you can do the same thing with Nodemcu as well. Connect the sensor to Nodemcu according to the shown schematics. Then upload the code to your Nodemcu. And you will be able to see the similar results. But getting output in serial monitor doesn't look very interesting. So we will use the OLED display to get the output on the display instead of serial monitor. So I am using a SSD1306 I2C OLED display. Now I connected everything according to the shown schematics, and you can download my code from description. But before uploading the code, make sure you install the SSD1306 OLED library in your Arduino IDE. Otherwise you will get a compilation error. After this is done, upload the code to your board. Now put your finger on the sensor and wait for some time, and after that you will be able to see your heart rate or pulse rate and oxygen saturation or Spo2 on the OLED display. Looks cool, right? So let's make it a more cooler by making a proper PCB for this project. So for now I'll be using this multi-purpose PCB board, and I'll be using this multi-purpose PCB board to connect all the components together. So now I soldered everything on this multi-purpose PCB board and it looks nice. So now let's connect the power and let's try this. So you can see that it is powered up. Now let's put our finger on the sensor. And as you can see that we are getting our pulse rate and Spo2 levels on the OLED display. And since we used the Nodemcu, so there is a scope for future improvement because we can add internet to this project with the help of Wi-Fi capabilities of Nodemcu. But that topic is for another day. So now as you can see that we are getting our pulse rate and Spo2 data on the display. But to be honest, this data is not very correct. So due to power issues of this module, as I told you earlier, it might work unstably. And sometimes it might give you wrong data or less accurate data as well. So be very careful with this module and think twice before using this to design a professional equipment. But it is good enough to be used for educational purpose. So this video is intended for learning purpose only. Please do not expect a accurate pulse rate data from this sensor. So anyways, this is a cool project to do and works up to some extent. So let me know what do you think about it in comment section. So guys, that's all for today. I hope you like this video. If you do, hit like, give me a share and don't forget to subscribe. And I will see you guys in another video of mine. Till then, keep exploring.